Okay, hello everyone. Hope you're all doing well. Sorry it's been such a long time since the last video. I'm very busy. Anyway, so today we're going to look at something called buffer overflow. It's quite a daunting thing to start learning, and I am still learning it myself. I'm not very proficient at it yet. I understand the basic concepts of what a buffer overflow is. So, a quick little overview for those of you who aren't really aware of what it is. So in a buffer overflow, what you're essentially trying to do is you're trying to take control of the flow of program and then redirect that program in order to try and execute your own code that you've sent maliciously. It's a little bit more complicated than that. I don't really go too much into it because there's lots of information out there on this kind of stuff. So basic concept would be, so you have this infamous program running here, and it takes an input of start real password here. So on the actual program itself, it will ask the user for an input, and as you can see here, the input has a buffer size of 20. Now what we're going to do is we're going to send the buffer that, and then we're going to overflow the buffer by generally thousands of bytes and try and crash the program. And if we can do that, then there might be a chance that we can overwrite part of the code in here and then redirect the flow of this code to execute our own code. So what we're trying to try and essentially do is take control of something called the EIP register and then find out where the ESP is on the stack, and then redirect the ESP to where our program is located on the system, and then that way we'll be able to execute our own code and then get privesc or access the box or whatever. So without further ado, I was introduced to a great little resource called TryHackMe. I recently found out about this from doing other courses on Udemy, and so I thought, well, I wonder if they've got any buffer overflow stuff on it, and I found this. I thought, wow, this is really good. So I did a buffer overflow yesterday, the first buffer overflow, using some of the write-ups that other people have provided on here, and it's just a really good learning exercise. So what I'd recommend when learning buffer overflow is literally just go on any kind of free resource, such as this one here, Rapid7 blog, and just read through the blog itself, and then just get practicing, really. And then from there, you'll start to understand what we're trying to achieve. So what we're going to do today then, so on TryHackMe, if you go to, I'm pretty sure this is free, but you get like obviously reduced sort of capability on the box on the website, and if you pay for it, you get increased capability. I paid for it. It's really good. It's only £8 a month, and I'm really impressed with it, to be fair. Yeah, so let's crack on with it. So if we go to learn and then tap in overview, there's oh no, all rooms even, and just put in OSCP. So if you're taking the OSCP as well, this would be a good little thing to crack on with. So I've already started this up, so let's kill that. So what you want to do is start on, get rid of that one. I'll go through these over the next few weeks and we'll work through it. So I started on this one yesterday, so what we're going to do, we're going to start the machine up. So start machine, and then that'll do its thing there. You'll see that come up. And then start attack box, so make sure you use the Kali Linux box, because if you use the attack box you'll have a connectivity issue, which is what I was getting yesterday, and I wasted a hell of a lot of time with that. So yeah, make sure you don't do that. Now, I went through the tutorials on this, so if I was you, as a beginner, don't try and work it out yourself, because you'll just bang your head against the wall and it'll be really stressful. So it's a bit of an easier session today, because there's not going to be any kind of craziness trying to work out hacking or whatever. We're going to what we're going to do is we're going to yeah, sorry for this box to kick up. Yeah, so I used a little write-up that was on here as well. I can't for the life of me find out remember where I put it, where it was actually. Use some, yeah, it's really useful. The write-ups, here we go. I use the top one, which is really good. It could have a little bit more detail, but to be fair, I'll come in with this video. You'll be winner, chicken dinner. So yeah, just go onto this page and follow it along here. I'll move it off screen so I can follow it as well, because I can't remember what I did. But I'm going to write this up on my website as well. So yeah, let's crack on. I'm going to put this out of the way. That is on my screen over here now. You can't see it, but if you want to do the same, they're great. Split screen it, whatever. Okay, so let's go to the right up then. So what we're going to do is we're going to use. Sorry, let's go back. What am I doing? Quick. Right, this one here. So this is basically RDPs to the attack box. You see here that? I was actually working on this yesterday and this address updated. It kicked me off my machine. It's so annoying. Anyway, so in order to use the clipboard, click on that, paste it in there, and now it's on here. So open up a little terminal. You can do all this from your web browser as well. This is why I really like this. You don't need a powerful machine or anything. You can use it off just any old machine. You've got your access to all this kind of stuff. Absolutely marvellous. Really good. Yeah, click on that. And then we will get an RDP session. And open up another terminal, because we'll need that for our other things. Oh, I wish I had more. I wish I had more real estate now. But that can go away. Click on the home network for that. And crack on with that. Okay, move that down here so we can have both up. That'd be nice. Okay. Okay, I think that should probably set us right, I think. It'd be nice if I had Terminator on it. I wonder if they do. Terminator. No, we don't have Terminator. I wonder if we can install it. This isn't necessary. Install Terminator. Can you install stuff on here? Looks like you can. Maybe record if you can. Yeah, buddy. Looks like they've. Oh, maybe not. Oh well. It's only a learning thing. So let's put these side by side. Oop, up here, because we'll probably need that. Okay, so I'm going to follow this, and I'm also going to follow the TryHackMe buffer over prep write up that we're seeing up here. I'm going to be following this one. Yeah, so without further ado, let's get underway. Let's get rid of that one now. Go on to task 2, and then we're going to netcat. So it says here, right click on Immunity Debugger. So this is Immunity Debugger. This is what we're going to be using to find our buffer overflow. Now, you'll find Immunity Debugger is used quite a lot on these buffer overflows because it's nice and nice sort of way of learning how to do buffer overflows. But obviously in a real life scenario, you're not going to have full control over the program in question. So in this setup, this scenario, yes, I know that you wouldn't be doing this way for real, I imagine. This is just for learning exercise, but it's still useful. Okay, so here we've got to find our program. So we're going to go File, Open, and then we're going to find, what is it, Attack Tools or something? It's Desktop, I'm sure it was. So let's go to the top. And then we'll find, oh, I've messed that right up. Oh, Windows, users root, admin, desktop, Vulnerable Apps, OSCP. There we go. Now in this instance, this is the program we're going to be overflowing. But yes, it looks daunting, horrible, and all kinds of crazy stuff. It does look disgusting, I'm not going to lie. I mean, I'm not still fully to grips with all this kind of stuff yet. Yeah, so if you're struggling to get through this as well, don't worry. This stuff is hard, so don't get disheartened by it. It takes a lot of time to get through this. Like I say, this will be my fourth buffer overflow lesson ever. So yeah, do not worry about it. Okay, so this program Mona will open in a frozen state. So what we're going to do, we're going to press play, and that'll run through it, and it'll wait there for us to do stuff to it. Now we're going to have to be closing this down, opening it back up again multiple times, because obviously we're going to be crashing the program, so we need to restart it again. Okay, so to check that it's working, what we're going to do is we're going to netcat. Netcat to here. So we will see something listening on that port. Netcat cat 10.10.92.127, and then port 1337, and then we'll get a welcome to OSCP vulnerable server, and to help for more information. So we go help, and we're going to get that. Then, as per our instructions, I might make this bigger actually. We'll just follow the write up. That'll probably be a little bit better. Down here, if you press that button there, is this going to go full screen? Yeah, it is. Yeah, it is. I like this. I like this website. It's very good. I definitely recommend if you're an up and coming hacker, you're learning to get some increase your skills, I definitely recommend this. I'm not paid by them, by the way, so don't think I'm just saying that to get some extra dollar, because I'm really not going to get anything out of it. It's just a fantastic resource. So here we are. So we'll follow this as we go. So ignore all that. It's Overflow1. Here we go. Okay, so here we are. So we've done all that. We've been through that. Here comes Overflow. Okay, let's do the Overflow test as per what it says here. So Overflow 1 test, and it should say test succeed or something like that. Here we go. Cool. This is where it says here, and now we can disconnect from here. Okay, so everything looks good. Let's configure our monitor. We can check log data. Okay, so you'll need to do this, because then this creates a little working directory for Mona to work from. If you don't do this, you will be upset later on, as I found out the hard way. So we'll need to do this multiple times as well. So a lot of these commands we're going to have to do multiple times, so it doesn't. So we're going to need to do that. So sorry, that's just that has copy and pasted in there. Let's try and get that nice, you can see it. Here we go. Cool. So that creates a little working directory that we're going to work from. So put that in there. What are we doing? Okay, enter. Okay, don't worry, that's meant to happen. So from here, to go back to where we were before, window, CPU main thread module, back to here we are. Okay, I should have probably made sure that we've got this little value in here. I'm sorry you can't see that. I'm going to make it bigger. Yeah, I can. Yeah, it's better in it. Here we go. So we're going to config state working folder 2. Perfect. Okay, let's try to run fuzzer from the room. So there is actually a little Python script located on the website. So before we can go further, we need to get that fuzzer from the website. Oh damn, what am I doing? Wrong button. So what we need to do, go back to har, and if I go down to here, this is the fuzzing script. Copy, go back to here. Oh no, it's gone Pete Tom. I'll go with that. We just made it bigger down here. It does that, it's weird. So in here, we're just going to put, make sure we know where we are. We're in root. So let's change the desktop actually. So ls cd desktop ls. Okay, so if you just go nano fuzzer.py, and then we paste our code, paste clipboard. Is it going to work for me? No, it's not. It's just going to freeze on me instead. Yeah, it's good that, isn't it? Anyway, so we'll just do it this way instead. Paste. Oh, for goodness sake. So, pot. There we go. What if that'll work? Yeah, there we go. And then paste clipboard. Okay. So what this is going to do is let's look through the code. I mean, it's always good to look through code, try and understand what's going on. So it's importing the socket. So this will open up sockets on your system. That's what that is, and that's what we're going to do around here. So our IP variable is at port and then timeout. So we're setting variables here, and then that's about setting a dictionary, I think it is, and then counter, so that will increase, as you'll see when we get down there. So our counter plus 100. So every time this goes through, counter gets plus 100 too. So basically we're appending A's times however many the variable counter is. So as long as the length of buffer is less than, that's less, I get confused with that, less eats, yeah, so less than 30, append an A times however many the counter is at that time. So that's a little while loop. For string in the buffer, so for values in dictionary, do this, or try open up a socket, so then you pass socket to timeout, so it must be given it a 5-second sort of delay before it sends its packet, and then connect to IP port, must be the size of the packet or something, or size of the that's to receive, that's what it's expecting to receive. Yeah, so it's S is receive size, print fuzzing with, yeah, so it's going to print out to the terminal length of string, so whatever string is, string in the buffer, so it's be telling you however long, well, buffer, where's string, buffer, length of buffer, yeah, send is overflow plus string. I see. So when we did our netcat, we send overflow test. So that's the test is the field we're testing. So it's going to send the word overflow plus however many A's are in the buffer. So however sub big this is. I remember that's that is equal to that. Telephone receive, and that's going to close the connection. And then once it crashes, so could not connect to IP, so that means we've crashed the program. So that's what that is doing. So that's just basically it's sending our strings to the socket with an increasing amount of 100, increasing the amount 100 every single time until we break it, basically. That's what that is doing. Okay, so let's go down to here. So what we've got then. So we've got a Python fuzzer. So we'll just run it. Python fuzzer py. Okay, that's going to keep going then. That's not 5 seconds. I don't know, 5 milliseconds then. I don't know. Yeah, that's going to be doing that until it crashes. Okay, so I imagine it's going to get to 2000 bytes before we get a thingy. So if you can see it's up 2000 bytes, which means the offset would be in the range of between 1900 to 2000 bytes. Let's create a pattern of more than our offset of around 400 bytes, which would be 2400 bytes. So there's multiple ways of doing this. This way is a nice way of doing it. So what we're going to do, so what we need to do now, so what is happening here, our program has been has crashed, and if you can see here in the EIP, so you can see the data that was sent. So at the top here you have overflow plus all of the A's that we sent, and if you look at the EIP register, you'll see 41, 41, 41, 41, which is A's in hex. So that is proven, because we were sending a load of A's, a shit ton of A's. Like see here, we've proven that we've overwritten this program. So the reason why the program crashed is because the EIP points to the next part of the code, and so the location of the next part of the code, I believe that's correct anyway. So what's happened is we've written A's in there, so it doesn't know where to go, so the program's crashed. So that's what's happening. That's why we need to keep restarting this. So we've proven that we can overflow the buffer. So what we need to do is now we need to create a unique pattern. So what we need to do first of all, we'll restart this. So open, I think you can do it this way. I think you can. OSCP start. Let's just check that. Netcat. Yeah, that works. Fine. So now what we need to do is we need to create a unique pattern so we can find out roughly where or how many bytes it takes to overwrite the EIP part of the register. So what we can do to do that is we can use Msf Pattern Create, and we're going to do it to 2400 because we crashed at between 1900 and 2000 bytes. But just to be on a safe side, we'll add 400 bytes just to make sure we do overflow the EIP register, and then we can find out exactly where we overflowed the EIP register, and then we can start redirecting the flow of the program. So what we do, Msf Pattern Create. Okay, that'll take a minute. And then on this side, what we're going to do is we're going to go nano fuzzer py, because now we want to change the desktop, CD desktop. And we go nano, or we go vim, well, fancy vim. The vim buzzer py. And then in here, we got our buffer. Was it payload? Payload we need to use. What am I doing? So, sorry, forget what I've just done. Don't follow me on that. So what we're going to do, we're going to have to go back to our thingy slightly. Because, actually, we do it on this one because this one's better. We do it on the left one. The left one's better. It's got better. The chap who wrote this, or the person who wrote this, he's modified the script a little bit, and his modifications have actually made it a little bit better. So, what's he done here? So copy the payload, exploit. Yeah. So let's go to exploit. Is that it? No, let's just find exploit. So let's go back to there. We'll just get the exploit code from here. Have I got the wrong one? That's fuzzer. That's fuzzer. Crash notification controlling EIP. Hang on. Let me just catch up with myself. Okay, yeah, so caught up with myself. So on the original page on the TryHackMe thing, if you go to the payload script and then copy that, and because I'd recommend keeping it for yourself as well, just for the future, put it somewhere handy, because it will come in handy. Yep, save that into there, and then in here we'll create another file called payload.py, or was it exploit.py? I'll keep it the same. Exploit.py, then we'll just paste that into there. Paste clipboard, then Control 0 or O, Control O with an X, just Control X to get rid of that. Okay, so we go back to here then, back to being big, and we go nano exploit.py. Okay, then ESR stuff. So it's very similar to the fuzzer really in a lot of ways, except it's more kind of specific. So we set our variables up here, then these variables are passed to this function, and it will send it to the thing we're attacking. Right. So what we need to do in the payload, I think it is. So we take our random unique series of characters generated by Msf Pattern Create. Come on, what are you doing? Cracking all over the place. Stop moving about. Here we go. So copy selection, and in the payload area, as per the specifications over here, go to copy the payload, put it into payload variable, and then run it. So what we need to do here, and in the payload area, this bit, so paste clipboard. Okay, so basically this is going in here, so it's to generate a unique set of characters. Okay, so that's better. Yeah. So Control O to write out an X. Okay, so with this running, this is fresh and running. We go Python exploit dot py and then we don't run it because I can't type. We do that and we crash it again. So what we need to do now is get rid of this. We might have to reset this every single time, I'm not sure. And then we go to Mona, find MSP distance at 2400. Okay. There we go, paste, do that, and then we should come up with this. Let's see if this works, shall we? Okay, so we're looking for, you can zoom in. Oh, I can't go even more. No, I'm sorry, this is asking this as big as I can get it. So EIP contains normal pattern. So we're basically looking for the pattern in the EIP. And we're looking for that offset there, 1978. So if we look somewhere along here, fortunately there is no easy way to do this. It's just basically squint your eyes and start looking. So 2400, I've got 2400 down here, look. Looking for that, going to find MSP. So imagine there's a cyclic path underneath it, and then here we have it. EIP contains normal pattern, offset 1978. Okay, so our EIP register. So if we go back up here, EIP, so that should match what we've seen down here on here. So it won't match here. That's part of the tutorial, but oh yeah, it does match. Yeah, so that's expected. Okay, so this matches here. So at position, at byte number 1978 is the EIP register location. So what if we do now, we'll restart this, and just to prove we know what we're doing, what we're going to do, in our payload, we are going to go, we could do Vim this time, and there's a reason why. So Vim, exploit, okay. Okay, what we're going to do is we're going to delete our payload because we now know where the EIP register is located. So if you go into payload and then press DD twice, or D twice, you'll basically delete the entire line, and it's all one line. You can just delete it without messing about. Within Vim, so this is Vim. So Control I to interact with the script or whatever, and then just type in payload because we've deleted it. We've got to replace it. And then double quotes. Oh damn it! Come on, I'm so stupid. I haven't got time for this. What? Why doesn't that work? That's amazing. That is one of the most amazing things ever. Oh, crying out loud. We weren't doing this yesterday. Hang on, I've got to find out how to do double quotes. Come on, you mother. Come on, here we go. If we you're taking a minute. What is going on here? What? No, I don't want to stop it. Go away. For God's sake. Right. DD. Fuck me. Right. In there. In there. Right. Payload. Don't do anything mental. Just put double quotes in. What? I didn't even know how I did that. You're having me on. Right, we're going to try that crazy thing again. Copy. Right. Highlight it this time, so middle up. Oh my god. Why? Why? Just double quotes. It's like the actual key itself isn't working. It's really weird. Alright, so this. We're going to do nano. Nano. Exploit. No. Go away. Why is that being modified? No one's modifying it. Okay, I think it's Control K to get rid of a line in nano. Yeah, it is. Right, payload equals. Oh my god. Why is that? What is going on? I'm gonna stop recording there. Sort this out. It's bloody. Okay, I don't know what's going on there. Something mental. I don't know. Anyway, so we now load our offset. So now in our offset, we're going to put something along the lines of 1978. I do believe. Yeah, 1978. Now that is our offset. Now, the overflow RTN value. Yeah. So as you can see here, overflow is going to be all A's times this many, and then on the RTN value, we're going to put BBB just to prove we've got a control of the EIP register. So BBBB. Right. Oh, cancel. And then we're going to run it. Python exploit.py. And as you can see here, we've got 41, 41, 41, 41. So it hasn't actually gone according to plan at all. So in my haste, yeah, it has done it. So I'm paying attention. So yeah, as you see, A is 41 in hex, and then B is 42. So yeah, so we only have one instance where we chose the B's, and that is 4 B's. So so 2 values equals 1B. So 42 1B, 42 1B, 42 1B, 42 1B. So that works just fine. Okay, so we've now proven that we have control of the EIP register. So now what we need to do, we've done this bit, so let's get it running. So we've just proven that we've got control over it, 42, 42, 42. And then as we can see, the register is overwritten with BBBBB. So as far as we know everything well, now it's time to look for those bad characters. Yeah, so in when we're looking through both overflow stuff, we need to identify bad characters that will stop the running of the program. Yeah, so because you'll probably find if you generate some sort of code, and then it doesn't code, you'll see a certain aspect of that code will have a bad character, and it will stop the flow of the program, and you'll get code execution. So in order to do this, it's not too bad. It's not as bad as it sounds, to be honest. So what we're going to do is, once again, we're going to get this running because it's obviously crashed. So we're going to create a byte array, so we have something to compare to in Mona, in Unity Debugger. So paste, create a byte array, and then should say location saved. Now this is where we used the working directory from earlier on. Done. Wrote to this file, so OSCP byte array.txt. Done. Wrote 250 files. 2. Yeah, where we expect. It's fine because we created this working directory earlier on. So this is where you created it earlier on. If you've closed Unity Debugger, by the way, and reopened it, you're going to need to go back up to the top, and you're going to have to recreate a working directory. Otherwise, this won't work for you, and the fewer steps go next won't work for you. So that's what I found out the hard way also. So yeah, so don't do what I did. Okay, so let's go back down to here. So now we need to generate a string of bad characters identical to the byte array. Use the Python script provided inside the room, or you can use mine, which I've modified for the next step. This is the code I was talking about. His code's really good. He's made a little bit of a sort of more customizable area here, which is really useful. So copy his, I would recommend. So go to har, and go to har, put that in there. Okay, and now if you go to, again, we're going to go nano, what's he called it? I'll call it byte array or something. Byte underscore array dot py, nano, and then we go paste clipboard. Perfect. And we're going to go write that. So this first one isn't going to have any bad characters to remove from the byte array. So we're going to just generate a normal one. python byte array.py, and that basically gives us an array of all possible hex characters, combination of hex characters. We go copy selection, and then so basically this can be identical to what is in Nona, and then we're going to compare the two, and that'll give us our bad characters. So we're going to put this into our payload as specified here. So nano exploit.py, and then we go down to payload, and then we're going to go paste, and it'll probably go something crazy. Oh, I didn't do anything crazy this time. It just did literally nothing. So what we're going to do is come on, stop messing me about. Here we go. Here we go. Paste clipboard. Here we go. Perfect. Write that out. Oh, for God's sake! I don't know what it's about. Fat fingers. There you go. Go. Cool. Right. X. Okay. So what we're going to do here? Make sure this is running. I think I did that. Yeah, it's running now. So hang on a moment. Yes. So where were we? Okay, so let me just come back to this. Okay, so this is now running. So we're going to go back to the CPU main thread. Pretty sure this is running. Let's press the button again. Yeah, it's now running. The IP hasn't been overwritten, so we haven't run anything. So now, if we go Python export, because now this has our byte array in there. Click on that. That crashes it as per what's expected. I changed this to all C's, so we're still overwriting the EIP, which is fine. And now run the so let's just go back over this. So run the script and take note of the address to which the ESP register points. So the ESP is basically going to be pointing to where our code is located. Okay, so we want to take note of that now, because this is where our payload is located. Okay, so ours is located here. So let's copy section of the clipboard. Let's hope it actually does it this time. Using the following Mona command. So this is going to find our bad characters. So copy all of that. Copy. Put it in our little clipboard, so I can't be asked to be can't be bothered to be messing about. Paste. Okay. Copy. Probably didn't need to do that. And then put that in here. Paste. This is going to take us to our address from this here ESP. So right click. Copy section clipboard. Goes on there. Paste. And then this should happen. If this doesn't happen, it's because there's a strong chance you haven't configured the Unity debugger to run correctly. So when we talk about the settings, you're the one with our byte array and our working directory. Configure that, and then come back to this. So this is going to tell us what our bad characters are. So if you come down to here, I can't see if you can zoom in a bit. Oh, you should be able to do it on yours. You'll see corruption after 6 bytes. So these are the bytes. So, but there is a little caveat with this. These are possible bad characters. So in a real scenario, these are possible bad characters. So here it says, so we found a list of possible bad characters. Not all of these characters might be bad. Sometimes bad characters are caused by the byte next byte to get corrupted as well. So, or even affect the rest of the string, and after try and error. So yeah, keep doing this basically. So in this instance, this is what happened. The first character has caused the second character be included as a bad character. So in this instance, the bad characters are actually, this makes no sense, but anyway, the bad characters are actually, so ignore the first one, because that's usually no operations. So ignore this character, this is the first character. That's the bad character. So bad character, good character, bad character, good character, bad character, good character. Okay. So yeah, these are our bad characters. So what we need to do now is we need to remove these bad characters when we create our payload. But that comes later. So take a note of these. Plus we're going to have to restart this as well. So we've got our bad characters. Let's go really generate a new byte array in Merlin with our updated bad characters performed. So as per the modified byte array this person has created now a byte array. So basically said list ram split. I think it's, I can't remember where we put them. I think it's here actually. Yeah, it is there. So basically saying he's created a little list. He's saying create a byte array minus bad characters, and then we're going to test it. So list rem. Okay, I was wrong. Okay, so you put it in here instead. So our bad characters are 07. So as he's done in here, escape x07. So what we can do actually is be a bit of a cheat. But what you'd really do in a real scenario is, okay, consider this the no ops. So that's the no ops led. So you wouldn't consider that, and then that's bad character, good character, bad character, good character, bad character, good character. So then when we armed with that information, what we're going to do is going to go backslash, which is escape. So treat the ow fucking cat. Sorry, the cat just jumped on my bloody shoulder. Arsehole. Sake. Uh, 07 x2e. There he is, x2e and AO. So backslash to escape the next one, and then x2e, was it, or alpha 0? Alpha 0. Okay, so here's our bad characters in here. So that will create a list minus bad characters now. X nano byte array Python nano exploit Python byte array. Okay, you probably so here we go. Copy selection, and we go back to our payload. Python exploit.py or nano exploit.py. Now what we're going to do is Control K here again, and then we put the payload in equals, and then that way. Oh, for crying out loud! Then it's done his favourite thing he likes to do to me. For Christ's sake. So I'll paste our payload there, paste clipboard, and then what we can do there is just highlight that, put that in there. So how yeah, I didn't see that. Paste clipboard. There you go, perfect. So there we go, and then Control O, enter, and Control X to get out of it. Okay, so we need to restart this. So file, open, OSCP, start. Sorry, and then start it up. So that's now running. Okay, so we then need to run our exploit again. Python exploit.py. Oh, what's gone wrong there? Oh, that's to put it in the wrong place. Oh, what I've done now. Okay, so me, my infinite wisdom, I spelled payload wrong. So, what? Control 0, O, X, okay. And then that's good. We crashed the program again. Okay, so now we're gonna look at EIP, ESP, that's pointing to. Okay, it's pointing to a new location. Okay, so we're just gonna change that. The byte array should already be included. So I'm gonna risk it for a biscuit, and we're gonna see where it points us. So 0194 FA30. So that should work. Yeah. Okay, I still got a bad character in there somehow. So we're going to have to redo all that because I'm an idiot. So give me a minute if you'd done yours correctly, that wouldn't have happened. So let me just take a moment, sort that out, and I'll be back with you. You can either skip the video forward or watch me mess about with it. Totally up to you. Okay, so I'm going to go back to my ls nano buffer. Is it buffer? What do I call it? Byte array. Byte array. Nano. Okay, so why is that not playing? Why is that playing at AXA0? That looks good. Split. Yeah, that's good. Okay, perhaps I copied the wrong thing. Okay, let's do that again. Exploit Python, that's not the one. Nano Python byte array. Yeah, okay, we got you. Is you different to the previous? Okay, the previous byte array was that long. Yeah, so we have taken the bad characters out there. So I don't know why that's happened. Bad chance. Why is that 07 still in there? And 2E and AO. So weird. Split on the X. Is that what's happening there? Okay. Okay. Go there. I think I've done something wrong here. Copy selection. Let's have a quick little look at that byte array again. Yeah, split on the X. Yeah. Aha, something's not quite right. Oh. Okay, we'll leave that. Okay, let's just redo the Python nano exploit. Yep. Okay, so I want to get rid of this payload because I reckon there's something wrong with it. Okay. We're going to put the payload back in there. Spell it right this time. And then we're going to, oh for God's sake, this piece, that again, this again. So this time, hopefully, paste clipboard. So we'll just quickly check for that 70. Oh, come off it. Okay, so 070 is not in there, right? So I've probably done something wrong with the payload. So let's try running it again. Repeat the same process in the ESP register. Okay, let's just go back to the top here, make sure that, yeah, payload offset's correct. Yeah, okay, so what's he expecting to see? He's expecting to see unmodified. That's what I'm expecting to see. Okay, so what we're going to do, so write that then, exit, and then we're going to restart this because it's crashed. File, open, OSCP, run. That's now running. And then we're going to go Python exploit tab. Here we go. And then that's going to burn that. That's good. And then we're going to compare our byte array again. Copy selection to clipboard, copy, paste. There we go, do that. And we still have bad characters. I don't know why. Oh, for fuck. Right, so I understand what I was doing. What we need to do is we need to create a new byte array in Mona, which is what I wasn't doing. So, yeah, I'm an idiot. So, the code was fine. I'm just a moron. So what we need to do now is we need to open up, restart all this stuff again. So that's fine. Create a new byte array. Copy. And paste. Okay, creates a new byte array for us. Lovely. And then we go back to our CPU window. And then this now needs to be running. This now running. And then also update the payload variable, which we did do. We updated our payload variable. So let's try running it again. So let's try running it again because we updated our payload variable already. You saw me messing about with that before. Okay, that kills that. And then we go back to that command. No, we need to do this. So go back to this command where we do the comparison thing. So we need to this bit because ours is going to be different. So get rid of that, paste, and then we find the location of our register just by there. So we go copy, and then we go paste. No, we don't do that, do we, Mona? Do that, and then we should see nothing. Magic, magic, woohoo! Unmodified. So basically, this confirms to us that there is no bad characters in all of this. So now we confirmed what our bad characters are, we can generate a payload. So this is the bit where we get our privesc and we, get a nice little pat on the back. Okay, so found our list of bad characters, la di da. Okay, so obviously this needs to restart now. So open. Okay. So this is going to be the time where we actually open up our netcat listers and start getting some stuff on the go now. So netcat dash nlvp 4444. Okay, just listening. Okay, so repeat the bad comparison to the result status unmodified, and we saw that in the previous video. Got listed up there. You can see it on your script or write-up. Repeat the bad character comparison until the result status returns unmodified. This indicates that there are no more bad chars. Let's find a jump point using the Mona command again. Okay, so this is where our code is going to be located, I think. So, okay, so found, sorted out our bad chars. Now we're going to generate a Msfn and reverse shell listing our bad chars. Generate a little payload. We'll stick that in our payload, and then we'll find a place to jump to in our code using this, and then put that in our RTN, and then that'll jump to that part of the code where our payload begins, and it'll execute our code. So what we need to do now is find a place to jump to. So okay, right, yeah, so I caught up now. So ignore this, clear that. So now I can find our jump point. So ignore this, go through this in a moment. So I need to, I've run the exploit again with our updated information. So now we need to find a jump point. So take this command, stick it in Community Debugger, and get nothing back because I didn't crash it, did I? Yeah, so apologies. So what I should have done is, what I didn't show you. So I did actually crash the system, and we did actually run a command, but it went back to this page. So what we need to do is go to Window, go to Log Data, and then Log Data, you'll see found total of 9 pointers. So we've got to choose a pointer that has a false ASLR. So this is some kind of, I can't remember what it's called, it's like some kind of defense against buffer overflow. So in this instance we're going to choose that value there, and this goes into our RTN, I do believe. So so back to our log. Double clicked on it, didn't I? Yeah, that's dangerous. So we write that value down. So once we've got that register, find a jump point, update our RTN variable. So in here we go to nano exploit py, go to our RTN variable that is located somewhere in here. Here it is, BBB. Yeah, so updating the EIP with this variable, and then it will jump to our code. So as it says here, because the software or the system we're using is something called Little Endian, we got to put it backwards. So I'd recommend going away and reading about Little Endian and various different things like that to fully understand what I mean by that. This is just a walkthrough to go with the TryHackMe stuff. So go away and definitely learn that. So what that means for us is we have to do this backwards. So it's really hard to see here, but you'll see there's an AF there. So in here we put backslash X AF, then backslash X, and then it'll be next one, which is 11 error 1 1 X backslash X, and then another one is 50 50 X, and then 62, and then that is our location of where our code's going to be. So that's good. Okay, now we need to update this payload as well. So we've got a payload in here that we have got from Msfn. Now to generate this payload, all you got to do is, let's copy that for a moment. File size payload B, copy selection. So all you got to do is use the command that's located down here. So Msfn, choose a Windows reverse shell TCP. Our host, then put in your IP. Our port, put in your port, and then bad bytes is the ones we used earlier on, and then other bits for Msfn. So we get rid of this in har, and this is nano, remember, so Control K, and then we'll put after that actually, payload equals, and I've got to do that stupid thing. I'll do that. I don't know if it'll work actually. No, it won't. Don't need to do that actually. And then let's go paste clipboard. And I've had the crash machine. Nothing's happened. No, nothing happened. Great. It's good that, isn't it? You highlight this again. Go down to the bottom. Oh, for crying out loud. Come on. Payload. Right click it. Copy selection. Go on there. Paste clipboard. And then that's our payload. So that just means payload B bytes size, and then plus equals to all the way down. So theoretically that should work now. So all we've got to do now apparently is run this and we'll get a reverse shell, and then I can go to bed. Let's have a look. Okay, so that is running. Let's open up a netcat listener over here. Netcat -nlvp 4444. Okay, and then so that's running, and then nano python, so python exploit just work. How's about that? Okay, it didn't work. Shocking. Okay, the reason why it didn't work because I didn't add any padding. Padding, I can't remember exactly why we have padding. It's something to do with making sure the beginning of the code isn't overwritten by the program. So you add some random like an ops led. So it starts, so the first few bytes of the code can be overwritten due to something else happening. I can't remember what it is. And then after that you have like an ops led. Like no operations where it just nothing happens, and then it hits your code, and then it continues to execute your code. So just put an upstairs, so put a series of X90s padding, yeah, and times that by 16 bytes, and that should be enough to protect our code from being overwritten for whatever reason. And then so we restart this, open OSCP, and then that's now running. And then if we just do that again, I should be able to go to bed. Oh, fuck off. Fuck you. Okay everyone, right, I worked out why it wasn't being a problem. Basically in my code I had a capital X instead of a lowercase x, and that ruined it. But now if I go Python exploit after, so everything we had set here was correct, by the way. So now if I just write Python1 exploit py, Oh my god. Okay. Nah, we should go. Yeah. So and we get a brief shellback. So we managed to get this program to execute our code. So there we have it. This is Overflow1 complete, and I will be moving on to Overflow2 and watch the space for the next video. Thanks for your patience and keep hacking. Bye bye or good night.